Okay, so here's a source transformation problem. Now, the way I know to use source transformation, even if it didn't tell me to, is because I have this set up right here with a voltage source and a resistor right there, and that whole thing is in parallel with a current source, and the current source is in parallel with two other resistors. And when I get resistors and current sources in parallel, then I can combine them pretty easily. So that's what I'm going to do. One thing you want to be very careful of when you use source transformation, if you transform that particular item, you want to make sure that you haven't changed the thing that you're measuring. And we'll see that on this one, that we are going to simplify this resistor, but we're not going to change the voltage on it. You'll see what I mean when we get there. So first we're going to change this voltage source and resistor into an equivalent current source and resistor in parallel. And it's the voltage across the 100 ohm resistor that I'm supposed to be measuring. And when I do this source transformation, a current source and a voltage source, a voltage source and a resistor, I'm going to get a current source. That current source will have the value of 250 over 25, which is 10. So it'll be 10 amps, and it'll be going up. This resistor will be 25 ohms. Now, I can also combine these two resistors, which are in parallel. The shortcut for simplifying two resistors in parallel, and this is only for two resistors in parallel, is product over sum. That's kind of a shortcut. It does not work if you have more than two. And so here, let's see, do I want to do that? I think I want to do, I think I'd rather do, yeah, I'd rather than doing those two, I'm going to do, just because I can do it in my head without having to get out the calculator, I'm going to do these two. Notice everything's in parallel, so I can pick any of them that I want to combine. Now, with the current sources, in parallel, I can also just combine them as well. So I have 10 going up and 8 going down. That's equivalent to 2 amps going in that direction. The two resistors I circled, the 100 and the 25, product over sum, so that'd be 2500 over 125, and that goes in 20 times, so that'd be 20 ohms. Yeah, that was a good decision. 20 ohms. Okay, now I do need to ask myself, this is where I mess myself up all the time. I just made a transformation of the very thing that I'm supposed to be measuring. So I could have messed things up, but I'm going to check and see, did I? Well, what I'm supposed to be measuring is the voltage across the 100 ohm resistor. And what I just did was I found the equivalent resistance of it with another resistor in parallel. So I actually did not mess it up because everything in parallel has the same voltage. If I was supposed to be measuring current, I couldn't have done that because the current through this 20 ohm resistor that I just made is not at all the same as the current through the 100 ohm resistor, but the voltage is, so it was okay to transform it. And similarly, I'm going to do one more transformation. The 20 ohm and 20 ohm are in parallel, and I can do product over sum. Or I can say, hey, I know a shortcut. If I have two identical resistors in parallel, the equivalent resistance is half. So when you have resistors in parallel, the equivalent resistance is always smaller than either of them. Okay, so now we are looking for, we want the voltage across this resistor. So V equals IR. So that would be 2 times 10, which is 20. So we know that the voltage is 20. And we want to make sure that we write it, make sure we have the correct sign. This was positive and this was negative, and we just want to ask ourselves, is this is 20 volts right? Is this side 20 volts higher than that side? And the answer is yes, it is, because that's the direction the current is going. And as we talked about earlier, the current is going from higher voltage to lower voltage, except in the sources that are providing power. Okay, so questions on that? No questions?